Good afternoon, ladies and gentlemen, and welcome to another session of Stop, Look, Listen, and Learn. Today we're going to talk about valuing stock options. We're going to look at two fundamental ways or methods to do that. And the first method we're going to look at is the one period binomial model. And then after we go through how you value a stock option utilizing that method, we'll look at a second method. So let's start off first with the binomial one period binomial option pricing model. So first thing we have to do is start off by looking at big picture of what it is that we're trying to do. We're trying to determine the value of a call option in this case here. So essentially the value of any asset is going to be the present value of the cash flows that it produces in the future. And so here, essentially what we'll do is we'll purchase an option, a call option on an underlying, and here we're assuming that the underlying will be a stock, say IBM stock. And 1 year from now, that call option that we purchased today is going to have a payout. And in this case, it's either gonna have a positive payout or no payout at all. And so what we want to do is take the expected payout 1 year from today and discount that expected payout back to today, and that will give us the value of the option. So that's big picture what we're trying to do. So now let's focus on some of the details in terms of how we actually do that. So first we want to do is look at some of the inputs that we need. So the first thing we need is the spot price, or the price today of the underlying, which in this case we're assuming is a share of IBM stock. So we're going to assume that the underlying price today is $100. And the second thing we need is some sense of the volatility of the underlying price. And here we're going to assume that the volatility of IBM stock price is 20%. And as I said earlier, we're assuming that the term of the option is 1 year. And then we need these up and down factors. So U stands for the up factor and D stands for the down factor. And as you know, a factor in mathematics is something that you multiply another quantity by. So that's the same case here. And so the way we define the up factor is by raising the exponential to the volatility times the time. So here we're assuming 20% volatility, so that would be E raised to the 0.2 times time, which is 1. So that's going to give us a value of 1.22 as the up factor. The down factor is going to be E raised to minus the volatility times the time period. That's going to give us a down factor of 0.82. And what we're going to do is we're going to multiply the spot price by the up factor to reach what we expect the price to be if we end up in the up state, and we're going to multiply the spot price by the down factor to tell us what the price will be if we end up in the down state. And an underlying assumption of the one period binomial model is that there are only two states of the world at time 1. There's an up state and a down state, and that's it. The next thing we need is the risk-free rate of return, and we're assuming that is going to be 5%. And then we need the strike price. The strike price is the price that we would be able to purchase the share of IBM stock 1 year from now. Now, here we need the probability that we're end up in up state and the probability that we'll end up in the down state for this particular method here. As you'll see, we won't need that in the second method. But here we define the probability of the up state as E raised to the risk-free rate times the time minus the down factor, all divided by the difference between the up factor and the down factor. So going through that arithmetic, we come out with the probability of being in the up state equal to 0.58 or 58%. And since probabilities have to sum to 1, we subtract the probability of being in the up state from 1, and that will give us the probability of being in the down state, which would be 42%. And then what we do is, as I said earlier, we take the spot price today, which is 100, and we multiply that by the up factor, which is 1.22. So that gives us a price of $122 1 year from now, assuming we end up in the up state. If, however, we end up in the down state, then our price in the down state would be $82. And that is calculated by taking the spot price a day, multiplying it by the down factor of 0.82. So we have the two prices that the stock can take on 1 year from now. So the next step is to determine what the payoff of the option would be in the up state and what it would be in the down state. In the up state, the payoff of the option would be $22, and that is because the payoff of the option is defined to be the maximum of the price 1 year from today minus the strike price, or zero. You're taking the maximum of those two things. So in the up state, the price of the stock 1 year from now will be $122, and the strike price is $100. So the difference between those two is $22, and you take the maximum of 22 and 0, so that gives you 22. So the payoff for the call option 1 year from now in upstate is $22. And we do the same thing to determine what the payoff of the call option would be if we are in a downstate 1 year from now. And we use the same process, so we take the maximum of the difference between the price at the end of 1 year and the strike price and 0. So here, the price in the downstate at the end of 1 year is $82 minus the strike price, which is $100. The strike price does not change. It is stated in the contract, so it remains constant. The difference between that is minus 18, and we take the maximum of minus 18 and 0, and here the maximum would be 0. So if we end up in the downstate 1 year from now, the payoff of the call option will be 0. And now that we have the payoff of the call option in upstate, and we have the payoff of the call option in the downstate, now we can make use of the probabilities that we created earlier. So essentially what we want to do is calculate the value of the stock today. And that is going to be equal to the expected cash flow or payoff 1 year from today, discounted at the risk-free rate for 1 year. And I'll talk about why we use the risk-free rate and not another rate that incorporates more risk. So here we take 58%, 0.58, which is the probability that we're going to end up in the upstate, and we're going to multiply that times the payoff that the call will provide if we end up in the upstate, and we determine that that is $22, and we're going to add to that the product of the probability of being in the downstate, which is 42%, times the payoff in the downstate, which is 0. And then we're going to discount that expected payoff by the risk-free rate for 1 year. And when we go through the arithmetic here, we end up with the value of the call option of $12.14. So that's the first method, and it's the one period binomial method. Now let's look at a second method of computing the price or the value of that same call option. So here we have basically the same inputs. So we have the spot price, which is 100. We have the strike price, which is also 100. We have the time to expiration, which is 1 year. And we have the risk-free rate, which is the same. And in this case, we're just going to be given the up factor and the down factor, whereas here we had to actually compute the up factors and the down factors. And very likely on the exam, they'll just give you the up factor and the down factor, but you should be prepared to calculate the up factor and the down factor if necessary. And here we're gonna introduce a new term, which is gonna be delta. Here we didn't have the delta, but here we will have the delta. And the delta is going to be the difference or the change in the value or the payoff of the call option in the upstate and the payoff of the call option in the downstate. And you're going to divide that difference by the value of the stock in the upstate minus the value of the stock in the downstate. So essentially what you're getting here is how much does the value of the call option change for a change in the price of the stock. So in other words, it's telling you how sensitive the value of the call option is to movements in the price of the stock, and is also known as the first derivative of the function, if you will. So here, there's a three-step process. So we start off by saying, okay, we're going to put together a portfolio that is going to comprise some shares, and it's going to be delta shares of the underlying or the stock, and then we're going to sell one call option, and we're going to say, okay, what is the payoff of that portfolio in the upstate, and then we're going to set that equal to what the payoff of that portfolio would be in the downstate. And here we have delta, which is what we're trying to solve for here, times the value of the stock today, the spot price, which is 100, times the up factor, and that gives us the value of the stock in the upstate. And we're going to subtract the value of the call in the upstate, because we're shorting the call and we're buying delta shares of the stock. And we're going to set that equal to the value of the portfolio in the downstate, which would be delta shares times 100 times the down factor, which is 0.82, and we're subtracting the call because, again, we're going to be short the call, and we want to subtract what the value of the call option would be in the downstate. And then we go through the algebra here and we solve for the delta, and you can see the delta is equal to 0.55. And what that means is that for every dollar that the price of the stock moves, the value of the call option will change by 55 cents. And that's because, as you can see, the difference between the payoff of the call option in the upstate and the payoff of the call option in the downstate is 22 minus 0, or 22. And the value of the stock in the upstate is $122 minus the value of the stock in the downstate, which is $82, and that's 40. And so 22 divided by 40 gives you 0.55, right? So now that we put together that portfolio, that enable us to solve for delta. So this is telling us how many shares we're going to buy. So we're going to purchase 0.55 shares of stock for every call option that we sell. Then the second thing we want to do, the second step in the process, is to figure out what the cash flows are going to be initially. So initially, the cash flow, when we put together the portfolio, the cash flow is going to be 0.55 times 122 minus 22, which is the call, which is what we're doing here. And that's equal to 0.55, which is the delta, times $82, which is the value of the stock in the downstate. And then we're subtracting the value of the call in the downstate, which is 0, because remember, we're shorting the call. And we go through the arithmetic here, and so we see the cash flow in year one, regardless of whether we're in the upstate or in the downstate, is going to be $45.10. And so that is going to be the cash flow 1 year from now, that this portfolio comprising delta shares of stock and being short one call option is going to produce. Then the third and final step is to, okay, say today we have to put this portfolio together. So what is the cash flow today? So if we're going to buy Delta shares or 0.55 shares of stock, and today and the stock costs $100, so we're going to spend $55 going long 0.55 shares of the stock, and then we're going to sell one call option, but we don't know yet the value of the call option today. That's what we're trying to solve for, and that's going to be a cash inflow to us because remember, we're selling the call, we're going short, and we're going to set that equal to what the cash flow is going to be in year one. Because remember, we just determined regardless of whether we're in the upstate or the downstate, the cash flow in year one is going to be $45.10. So there's no risk associated with that, no uncertainty. We know that if we're here, it's $45.10, or if we're here, it's $45.10, right? And since this is today and this is a year from today, so we need to discount this cash flow that we're going to get 1 year from today, and we discount it at the risk-free rate. And we use the risk-free rate because there's no risk or uncertainty. We know exactly what the cash flow is going to be 1 year from now. So discounting $45.10 at the risk-free rate and doing it on using continuous compounding, that is $42.90, which represents the present value of the cash flow 1 year from today. And then we just use basic algebra to solve for the value of the call option today. And we can see that the value of the call option is equal to $12.10. And the difference between the $12.10 and the $12.14 is simply due to rounding, right? And so, as you can see, those are the two methods of computing the price of the call option. And I've kind of summarized the methods here. So method number one is the value of the call option today is just going to be the expected payoff of the call option 1 year from now, discounted 1 year at the risk-free rate, and that will give you the value of the call option. Or the second method to determine the value of the call option today is to look at what the cash flow is today to put together the portfolio, and then once that portfolio is in place, we know what the value or the cash flow that that portfolio is going to produce 1 year from now, and we just simply discount that to figure out what the value of the call option is. So if we were to rearrange this equation, it would be the amount we invest in this today in the shares, so it'll be delta shares that we're going to buy. In this case, it's 0.55 shares. The spot price of the shares is $100. So we're going to invest $55 in the shares. Move this C over here. We're going to sell one call option, so we're going to have an inflow of cash, and that's going to be our portfolio: long shares, short the call option, and that portfolio is going to produce cash flow here 1 year from now, which is equal to $45.10, and then we discount that back 1 year using the continuous compounding at the risk-free rate using continuous compounding, and that will give us the value of the call option. And as you can see, both methods produce the same value. And I would say on the exam, if I had to guess, they would probably give you the up and the down factors, and you probably would have to compute the probabilities here. So I would definitely commit this formula here to memory so that if necessary, you can compute the probability of winding up in the upstate. And once you get that probability, since probabilities must sum to 1, you can just simply subtract the probability of being in the upstate from 1, and that will give you the probability of being in the downstate. And if you go that route, then you just use method number 1, where you take the expected value of the call option or the payoff of the call option 1 year from now, and you discount that expected payoff back to the present to get the value of the call option. And so that pretty much covers what I wanted to cover in this video here. So if there are any questions, please feel free to shoot me a note in the comment section, and I'll do my best to respond. And in the meantime, if you thought this video was helpful, please don't forget to subscribe to our channel. Thank you and best of luck on your exams.